So this is 3.2 in trigonometry, and the name of this section is Applications of Radian Measure, and I would assume it'll be 3.2a. It'll be the first video. The first formula that I want to throw out here is S equals R times theta, where theta is in radians. Theta is in radians, not degrees. Alright, so there's our formula. And what that means is that this length here, we're going to use this formula to find the length of this arc. If we know the radius here, and we know theta here, and we multiply r, the radius, times the angle in radians, theta, that gives me this length right here. And that can be really important to know. And we'll use some different word problems in order to solve that. So let's say that we know that 3 pi over 8 is the measurement of this arc in radians. And we want to find out how far it is from here to here. How long S is. So we know that. We also know that the radius is 18.2. So S equals the radius times 3 pi over 8. And we just multiply those two together and we get 21.4 centimeters. If I give you 144 degrees and I'm asking you to come up with how long the let's get rid of some of the stuff here. Alright, so instead of 3 pi over 8, I give you 144 degrees. So 144 degrees, in fact, let's just go ahead and do this and make our own stinking circle. Okay, good circle. Alright, so we've got 144 degrees right there. And we're interested in how long this is. Let's do that in blue. We're interested in the length of this arc right here. And that's our S. So S equals my radius, which I know is 18.2 from up here, times 144 degrees. Now, remember, you can't do this until your degree is written in radians. And that's one of the things you need to remember. Just like you learned back in pre-algebra, you can't multiply percentage. I can't take 20% times 30. I can't multiply 20 times 30. I have to change that percent to a decimal first. It's the same way with radians. I can't multiply 18.2 times 144 degrees. I need to change that to radians first. So, in order to change that to radians, remember we take our 144 and we multiply it by pi over 180, and then that will give us radians. So what we'll end up doing is multiplying 144 times pi, divide that by, I'm trying to find a calculator here real fast, 144 times pi divided by 180. Okay, that equals 2.5132. Now I multiply that times 18.2, and that gives me my 45.7 centimeter answer for the length of this right here, arc S. Alright, so that's example 1. Let's jump to example 2. Okay, so example 2 says we have Reno, Nevada, right there. Alright, it's approximately due north of Los Angeles. So from here to here is due north. It's right above it. Okay, the latitude of Reno is 40 degrees north. So here's the equator. So this is basically our XY axis, the north-south pole in the equator. And we just said that Reno is 40 degrees from the equator. Okay? And Los Angeles is 34 degrees from the equator. So we've got two different angles that we're looking at there. And let me go ahead and erase the stuff here so we don't get too bogged down with lines. The radius of the Earth is 6,400 kilometers. So from the center point to the outside is 6,400 kilometers. Find the north-south distance between the two cities. So what I'm looking for is the distance between Los Angeles and Reno. So notice I'm looking for S. I would be using my S equals R times theta, and theta would be in radians. So that's what I'm looking for. All right, I know that the arc is 6 degrees, or that I guess I should say theta is 6 degrees. So if I'm going to take 6 degrees, I've got to change it to radians, because remember, you always have to work with radians, and that gives me pi over 30 radians. My pi doesn't look very pi-ish, does it? I'm so OCD when it comes to this. Okay, pi over 30. So that's my angle. That's this angle right there, my 6-degree angle. All right, so the distance between the two cities is, again, S equals R times theta. So R is 6,400. That's the radius of the Earth, times theta, pi over 30. Our 6 degrees changed to radians. So when I multiply those out, I end up getting something close to 670 kilometers. Okay, let's jump to example number 3. So let's look and see what we've got. We've got a rope that's being wrapped around this drum. Okay, so it's being wrapped around this drum here. All right, what do we know? How much rope will be wound around the drum if the drum is rotated through an angle of 39.72 degrees? All right, so our rope starts being wound up here, and it says that that drum is going to go around until we go to 39.72 degrees. So what we're interested in is how much rope is going to be right here. As this thing turns on this axis, how much rope will we use to get from there to there? So this is my S, from here to here. And I'm using S equals R times theta again. All right, let's see what we've got. We've got a radius of 0.8725, so that's our R. R equals 0.8725 feet, so it's about almost 9 inches. The central angle is 39.72, and it's in degrees. So theta is 39.72. You need to change that to radians, so we multiply it by pi over 180. So we have S equals radius 0.8725 times 39.72 pi over 180. Okay, and you have to do the math to get that, and when you do that, you end up with 0.6049. So that right there is how much rope you're going to wind around that. Little over 6 inches it looks like. Okay, so that's example 3. Let's jump to example 4. Okay, so here's example 4, and let's see if we can move this a little bit. So what the book says is we have 2 gears, and they're adjusted so that the smaller gear drives the larger one. So this is where the force is. Moving this one, it's going to move this one. So as this one goes around, it's going to push this one down, and this one's going to go this way. So they're going opposite directions. This is going clockwise, and this will go counterclockwise. if the smaller gear rotates through 225 degrees, through how many degrees will the larger gear rotate? So what we're doing is we're taking this gear, and let's say that the teeth, it starts right here, and it goes 225 degrees. So this gear goes this far. They want to know how far this gear will go. That's what we're looking for. So, what we first of all need to do is find the radian measure of that 225 degree angle. So 225 degrees times pi over 180 is going to give me 5 pi over 4. 5 45 degree angles is 225. So there's my radians. So what we're going to do is we're going to try to find the arc length of the smaller gear. We're going to find this S right here. Okay, so S equals R times theta. So S equals the radius. What is that radius? 2.5. And we're going to multiply that by 5 pi over 4, which we got from up here, our angle. And that's going to give me about 9.8175. Okay, so that's how long S is. That's how long that pink line is. Alright, so an arc with this length on the larger gear corresponds to an angle measure theta in radians. So, what we have here is we're trying to find the bigger arc. We're trying to find out if this goes this far, how far do we go up here? Well, we know that the length is going to be the same. That length here that it's going to rotate 225 degrees is going to be the same length that is. So the length is going to be 9.8175 for both of these gears. But that's not what they asked us. They want to know how much this angle is from here to here. If this S here is 9.8175 and this S is 9.8175 and this angle is 225, what is this angle right there? And that's what we're going to look at. So again, if S equals R times theta, and we know that S is 9.8175, and that equals the radius, which we see is 4.8 on the purple gear, 4.8, and that is going to be multiplied by theta, and the theta is what we're looking for. So if we divide by 4.8 and get rid of that, and we divide those two, we should get our degrees, but it'll be in radians, not in degrees. So 9.8175 divided by 4.8, and the reason it's in radians is because that's what we've been doing this work in. We translated 225 degrees into radians. So therefore, that's what we're working for. So theta then ends up being 2.0453 radians. So let's change that to degrees by multiplying by 180 over pi. So let's multiply that by 180 and then divide by, see if I can get this right, and we end up getting 117 degrees approximately. I got 117.19, but that's how you do that one. It's a little bit easier to follow when I'm doing it than it is trying to do it on your own, I know.